Welcome everybody and welcome back to this tutorial. So today we are going to take back where we left the code and see how we're going to get the player moving. So before we start, as usual, the code is available on GitHub. The doc is available on Read the Docs. And you can contact me at hyrule.astronomy.club@gmail.com. Links in the description. So, last time we had this, we left the code here. So we're going to do some little changes to this code, so it's better. So reorganizing the code is called refactoring. So basically what we want is to have a better organization of our code, particularly to prepare the main code to be ready for the future. And in the future, our code is not going to be a mere 20-something line of code. It's going to be hundreds and hundreds of lines of code, and we want to be able to find quickly what we want in our code. And more importantly, we want to limit the occurrence of bugs, and these ones happens because you did mistakes in your code, but also because you had poorly organized code and you don't know what's doing what in the source code. So the first thing we're going to do, we declared here two variables. One holding 0, it's a counter, and it's supposed to tell the while loop when to stop. So as a reminder, while is a loop that runs until the condition here is false, or while it's true. So what's happening in this code for memory, for a quick memory refresh of the memory, we have a counter here, and while the count is less than 10, we do this part, and this part ends with us incrementing the count variable by 1. So we are going to lose all that, because actually what we want here is that this is our main event loop, our main game loop. Okay, so usually what we want is our main game loop to run forever, unless we have a specific conditions like the game's finished or the player wants to quit. So when we want the while loop to go forever, we need this condition to be true at all time. And the best condition is to use something that is always true. We could use like 1 equal 1, which is true, but we have a shortcut in most of the programming language, including Python, and we can just say while true, true being always true, do that. So we don't need count. And actually now we don't want to go from one level to the other. That's not our goal anymore. Also, you remember last week when I presented this part of the code, the display of the board, I said soon there will be a display board. Well, to do just that but faster, and that's here. So display board is the new function that is displaying the current board. Also, we're going to take the change level thing out of the main loop. We want this to be with our init code. and we don't want to use a variable that doesn't exist anymore. We want to change level to 1. Why do we want to do that? Because we want to init our game. If you think in terms of algorithm, the one thing we want is that the player enter the game in a first level, whatever the level is. It could be an introduction, it could be the tutorial level, it could be directly the first level. Uh, we it's not important. What's important is that the player starts somewhere, and then changing level is usually done by actions in the game. You get to the next level because you collected everything. Like if you take Pac-Man, for example, you're going to the next level um, when you have collected all the pellets. So that's a condition. You could be going to the next level because you walk through a door or a portal, whatever. That's not important. The important part is that algorithmically speaking, what we want to do is to set the level to the first level and then let the main event loop to take care of the level change. So here, what we want to do in our while loop, the first thing we want to do is to clear the screen. So remove everything that was written here and start with a clean slate. The second thing is to change to display the current board. So all of that is asked to the game engine, my game. Actually, I'm going to keep the sleep thing, but I'm going to put it to a very low value. Why would I do that? So far, if you're just beginning, don't worry too much about that. If you're not so much of a beginner, the first thing you have to think about is that game. If we keep refreshing the the game the screen, we're going to have glitches. Why? Because our game is going to run a lot faster, particularly right now. It's going to run a lot faster than the refreshment rate of the screen. I can actually show you that. So if I save that and I switch to the console and I run the game, so you can see that it's not very pretty. It's glitching, it's too fast. Actually, the while loop is running too fast for the CPU and the GPU and everything, basically the whole terminal, to display everything at the same time. What it means is that we have the first, as you can see, sometimes you see twice the cursor, uh, once here and once here, or somewhere in the in the middle. What it means is that the while loop runs so fast that it has to clear the screen before everything is displayed. We obviously don't want that. All right. Hence the slip there. By the way, if we look back at the code, suddenly with just 0.1 second slip, it's all good because it doesn't take a long time to display the screen. So let's get back to the code. Okay, so we have our main event loop that displays the screen. You have noticed that I have to interrupt the program to quit the program, so that's going to be a problem. So the first thing we want to do is to have a way to stop the while loop, like to tell the player, if you press Q, you're going to quit. So to do so, I will need to initialize a variable that I'm going to call key, and it's going from the none type. So basically we tell the Python interpreter, hey, I'm going to need a key variable, but for now I'm not putting anything inside. And so the last thing you're going to do before pausing for 0.1 second is going to get something into this key. So usually in Python we use the input function. Okay, so the input function lets you put the input take the input from the keyboard. You put a nice message here, and you're going to display the message and grab the key. The issue with that is that you need to hit enter. So the problem here is that we don't want the player to be hitting enter at all time, because it's going to be very painful when you want to move faster, quickly through certain levels. It de facto prevents us to code a game that relies on timing, for example. So instead of using input, we are going to use a method from the utils module of the GameLib, and it's called getKey. GetKey gets a key from the keyboard and do not wait for enter. So it's helpful a lot actually, and we want to do that before the sleep and after the display of the board and clear of the screen, because getKey is going to be blocking. It's going to wait for an input. So if you wait for an input while you haven't yet displayed the board, well, you know what, you get what I mean. You will have a frame of difference. And remember that the GameLib, the HAC GameLib, is turn by turn. So here we are with this get key. So now we get into key. We have the input from the user. By the way, there's a limitation to get key. Get key needs a key import, the keyboard input that only give one character. So that get key cannot take in consideration the arrow key, for example, because the arrow keys are sending key code, 3 key codes actually per key strike. So we need to get that out of the way. Hopefully in the future I'll have time to code the proper behavior for the arrow keys, for example. So now we have get key. We have to do something about that. So here we're going to create our key handler. So the key handler is going to be the piece of code that's going to say, hey, to translate the key input into actual actions. So for example, if my key is equal to Q, like quit, I want to break the loop and quit. And I could actually print a goodbye method. So goodbye message. So for example, I want to print a yellow bright message that says goodbye and thank you for playing. Now let's test that. So here I am. If I enter anything, it's not going to do anything. But if I press Q, I quit. And it's not right. It's not writing because the yellow bright function returns something. So let me show you how you fix something like that. Here we are. Now let's try again. If I press Q, goodbye and thank you for playing. So now you have an idea of how we're going to code the actual movement of the player. So remember, the player is already stored and managed by the game engine. Here, when we created the player, we directly affected the object to the player member variable of my game. So let's go and continue with that. So let's say that we want to use the WASD key. If your keyboard is not a QWERTY keyboard, it's not going to make a lot of sense, but for gamers that play with a QWERTY keyboard, the WASD key is looks like the arrows, and it's more practical. So let's continue on this convention. So let's say I want to have A for left. Okay, so I'm just going to leave it like that, left, and pass. If you have never encountered pass, it's a special keyword of Python that tells the interpreter, hey, pass your way. It's okay. Everything's right. Nothing's to say. Nothing's to see. So now we just have to build the conditional structure that takes the key and that look at what's inside and do the actual work behind. So now let's say key is D. D is going to be right. Okay, so right and pass. All right. So, and now W is going to be up. Okay, so we got key equal W, and that's going to be up. And of course now S, so key equal S, S is going to be down. All right. So now how do I actually move the player? Well, fortunately, the game engine allows you to do that just super easily. You do my game dot move player, and as you can see, you need to give it a direction and a step. And so the example is move player constant right 1. So the constants modules hold a lot of constants that are being used by the game, by the library, to have a common set of orders. So we're going to import this one. So we're going to import gamelib.constant now dot constants as constants. So if you're puzzled by these different syntax, you have gamelib is a directory, game board util sprites constant, and characters are files. Actually, if you look here, you can see my directory structures with one of the directory being gamelib, and you can see that we have game, we have board, we have utils, we have sprites, we have constants. So what we say is from the game file, game.py file that is into the gamelib directory, import the game class. Okay, so in the game.py there's only one class, that is game, but in character we have player and NPC, and there's many files where we group more than one class that is from the same type, like structures, for example, has many types, from treasure to wall and everything. We're going to see that later. So here, back to move the player. So here we're going to say, hey, I want this one is left. Constant hold all the direction, up, down, left, right, and all the diagonals from that. And I want my unicorn, because it's a unicorn, to move 2 steps. Okay, so let's do that for all of this. My game dot move player constants right. So I'm often asked by the kids, why do I put spaces here and there? Why do I have a space here? Why do I have a space here? Is that required? So no, it's not required, of course, but it's easier for reading your code, because what you write right now, you might be very you might be very you might be understanding very well your code right now, but you might not understand it as well and read it as well 6 months from now. So you have to make sure that you or other people that are going to read your code can understand what you were doing and what was your intention. And it's always better to read code that is not cramped and packed up. So here I've continued while I was talking to develop the rest of the movement. So I've got my game dot move player constant up 2 for the movement up, and my game dot move player constant down 2. I'm not sure this move two steps per turn is viable for the player, but it's a beginning. So let's test that code. So here we are. I'm pressing D, and the unicorn moves. I'm pressing S, and the unicorn also move. And there I'm keep pressing S to go down, but the unicorn cannot go close to the wall. That's because the HAC game library takes care of preventing the player or any object moving, actually any movable. We are going to see what's a movable later. But any movable it prevents the movement when the movement ends out of bound. So it's the same if I go there on the right, I can't go all the way right. And here, so we have a even number of cells, so I can never go all the way up down here, but I can go up here, and I can go right, because I started at 0, because 0, 2, 4, 6, 8, and 10. So the one thing you're not seeing, but you can count the walls here, is that it's a 10 by 10 matrix. The board right now is a 10 by 10 matrix. We can configure that. We're going to see later how to configure that. But it's a 10 by 10 matrix, meaning that the indexes are going from 0 to 9. So if I'm up here, I'm 0, 0, and then if I go down, my y coordinates are going to be 2, 4, 6, 8, and it cannot go to 10 because 10 is actually out of bound. But if I go up, I can go back to 0. That's why I was not so sure that 2 cells per turn was a good idea. So I'm going to quit the game and get back to the code to make it so it's only 1. So right now I'm using a special feature of Visual Studio Code, which is when I hold Control and click, it's creating multiple cursors. It's very practical because the mouse is moving very fast, and I can do that, and that's it. I've changed my movement amplitude. So let's go back to our game, and now we can cover the whole thing. Okay, we have our unicorn is moving everywhere pretty freely, and it cannot go out of bound. So that's one difficulty that you don't have to worry about, that your players or NPC will never be able to go out of bound. However, be careful because placing item out of bound is going to raise an exception. And that'd be all for today. So if I get back to the code for a moment and to review what we've learned today. So basically we've changed our code, so we have a while loop that runs forever or until we interrupt it by using Q, by hitting the Q key on the keyboard. Then we are using WASD to move our player up, left, down, and right. And to do so, we rely one more time on my game, on the game object, to move the player in a certain direction for one step. One thing is that if you have a keyboard, like a full keyboard with an alphanumeric panel, you could be interested into using the alphanumeric panel for movement. For example, 8 for up, 2 for down, 4 for left, 6 for right, and you could use 7 for diagonal left up, 9 for diagonal left right up, and so on. And this is no harder than the rest of the code. You just have to go with an additional condition, elif key equal. So let's say I'm going to start at 3. So that's 0, 0. So let's say I want to have 3 to go to move the player constants. Okay, so it's going to be diagonal, right, down, 1. Okay, so I'm just going to do this one so we can check that. So if I hit 3 now, I'm going diagonal. Ta-da! And I'm not going back because I need to I need to do that because I didn't code the other diagonals. So I encourage you to read the documentation on Read the Doc about the game engine, about the constants, and everything, so we can so you can see all the possibilities of this game engine, and particularly all the possibility of the constant sprites utils. There's a lot of helpers functions. Some of them might be refactored in the future, particularly as utils is also holding some constants the for display things. So anyway, thanks for watching, and I'll see you next week. For additional development, and we are going to start populating this board, probably with walls and structures like that. And it's going to be actually a very good opportunity for me to introduce the different kind of structures that are available from scratch in the HAC game library, and the one that you can actually develop by yourselves. Which is a bit more advanced, so we're going to see that later, but we already have tons of opportunities with the what's already present in the HAC game library. I hope you enjoyed that and have fun.